Welcome to today's revision question, and in our tutorial today we are going to be revising questions in physics. So question number 1 reads, a car has a mass of 900 kilograms. It accelerates from rest, which happens to be the initial velocity, at a rate of 1.2 meters per second squared, and that happens to be our acceleration in this case. So we are told to calculate the time taken to reach a velocity of 30 meters per second squared. Now if you look at this question very well, we have got some few information that's going to help us to find the time taken to reach that velocity. We know that acceleration is equal to final velocity minus initial velocity divide time. So we need to make t the subject of the formula. So when we cross multiply, we're going to have AT being equal to V minus initial velocity. Then you divide by A on both sides. Okay, that will make our T to be equal to final velocity minus initial divided by the acceleration. So if you look at our question, our final velocity, that is 30 meters per second, then our initial velocity, that is 0 meters per second, then our acceleration, that is 1.2 meters per second squared. So that will be 30 meters per second. If you subtract 30 minus the 0, divide 1.2 meters per second squared. So if you divide 30 divide 1.2, we're going to have 25 seconds. So this is the time. Then if you look at 2, we are told that the force required to accelerate the car at a rate of 1.2 meters per second squared. Now our force is equal to mass multiplied by acceleration. Okay, so in this question there we have the mass, which is 900 kilogram, multiplied by the acceleration, which is 1.2 meters per second squared. Now kindly take note, whenever you are finding the force, you need to make sure that the mass is in kilograms. Okay, if that mass is in grams, you have to convert it into kilograms by using this quantity where we say that 1000 grams are equivalent to 1 kilogram. So if you multiply there our mass, which is in kilogram, of 900 multiplied by 1.2, which is the acceleration, we are going to have a force, okay, of 1080 Newton. So that is the force in this question. So you may be wondering, what are these things that are being outlined in this question? There are a few things that we need to take note of. Number 1, we'll talk about the acceleration. Okay, what is this acceleration? Now acceleration basically is defined as the rate of change of velocity, rate of change of velocity. Okay, this is what we describe as acceleration. Then other thing that we need to take note of is that this acceleration, it can be calculated by final velocity minus initial velocity divide by time. Okay, so take note, the time needs to be in seconds also. Then another thing that we need to take note of is that acceleration, okay, is a vector quantity. Okay, now what do we mean when we say vector quantity? We are basically saying that this is a physical quantity, okay, which has both a magnitude, okay, and a direction. Okay, that's what we mean when we say a vector quantity. Okay, so next time we'll be able to look at other questions where we outline one or two things. So we can look at question number 2. Now question number 2, there we are told that figure B 1.1 is a graph showing how the velocity of the car changed when the driver applied brakes, okay, upon seeing a head of a car crossing the road ahead. So when the brakes were applied, this car started retarding, started from 12 there up to 2, then it maintained the same speed or same velocity. So it maintained at 5 there, okay, at 5 up to 10 it maintained the same velocity. So the question is saying use the information on the graph to calculate, okay, deceleration of the car between A and B. Now if you look at this graph there, this is our A there and that's our B there. So this is our at A, we've got our initial velocity, okay, which happened to be the 12 meters per second. Okay, at B there we have our final velocity, okay, which happens to be the 2 meters per second. Then the time taken for this car to retard, that started from 0 there to 5 here, this is 5 seconds. Okay, so what are we going to do? Of course we need to take the data. Okay, so if we are to carry the data, we have our initial velocity as 12 meters per second, then we have our final velocity as 2 meters per second, then the time taken there, that is 5 seconds. Then we need to find the retardation. Okay, now we are told that the retardation is the negative of the acceleration, so meaning retardation is equals to this minus excuse, meaning final velocity minus initial velocity, we divide by time. So this is equals to, what is our final velocity? Our final velocity is 2 meters per second. Our initial, that's 12 meters per second. Then you divide by time, which is 5 seconds. Okay, so negative there. When you subtract 2 minus 12, we're going to have negative 10. Okay, divide 5 seconds there. Okay, this is equals to negative 2 inside there, meters per second squared. Negative multiplied by negative, our retardation is equals to 2 meters per second squared. So therefore we can say that the deceleration of the car between points A and B, okay, is 2 meters per second squared. Okay. B, the question says the distance moved by the car in the 10 seconds. So if you look at this diagram there, okay, distance moved by the car in the 10 seconds, we have got we can be able to make two shapes from that, where we can say we have got a rectangle here, from there to there, the one that I've shaded in red, of which the base from that point to that point, the base, let me say the length becomes 10 and the breadth becomes 2. Then we have got a triangle, of which the base for the triangle from 2 there, where there's a 0, to the 5 there, that's a 5. Then the height of a triangle, okay, height from 2 to 12, the height becomes 10. Now we said that area, distance on the graph, distance, okay, on the graph is equivalent to area of the given figure. Okay, so we have got a rectangle there, and also I've got a triangle. So what do we do there? Which one is a triangle, by the way? Let me use a different color to shade the triangle. That's the triangle which is in yellow. Okay, so the base is 5 and the height is 10. Okay, for a rectangle which is in red, the base is 2 and the length is 10. So how do we do that? We shall say that the distance is equals to LB plus half BH. Okay, so our length there, it is 10 multiplied by 2, plus on the triangle, that is half, the base is 5 and the height is 10. So 5 multiplied by 2, sorry, 10 multiplied by 2, we're going to have 20 meters there. Then half multiplied by 5, then multiplied by 10, we're going to have 25 meters there. So the distance for the whole journey, that will be 45 meters. So therefore we can say that the distance, okay, moved by the car, okay, the 10 seconds is 45 meters. Okay, we can now find the average speed. So average speed of the car is equals to total distance covered over time taken. So if you look at our graph, we found the total distance covered, okay, as 45 meters Okay, then the time for the whole journey, that is 10 seconds. If you divide, we're going to have 4.5 meters per second squared. Okay, so